Today, let's interpret geometrically the factors of a quadratic expression of the type x square plus bx plus c using square grids. Let's begin by considering a quadratic polynomial x square plus 10x plus 21. Before we begin, let's split the middle term of a quadratic polynomial. Let's consider splitting the middle term 10x of the polynomial x square plus 10x plus 21. To factorize the expression, we have to split the coefficient of x into two numbers which, when added, amounts to 10 and when multiplied results in 21. The two numbers will obviously be 7 and 3. So, the expression when split would be x square plus 3x plus 7x plus 21. We will use 4 grids to verify the concept, that is, a grid for each term in the expression. This red grid here has 10 squares on each side. Let's represent the side with 10 squares as x. Hence, the area of this square grid is equal to x square. Here is another grid. We place this blue grid right at the base of the red grid. As we can see, this is a rectangle. It is length x with 10 squares and breadth of 7 squares. Hence, the area of this rectangular grid is equal to 7x. I have here a yellow rectangular grid. Let's place it next to the red grid. This grid has length equal to 3 squares and breadth equal to 10 squares or x. The area of this rectangular grid would then be 3x. What do we get when we add the areas of these three grids? Yes, it's x square plus 7x plus 3x. But the arrangement is not complete yet. We have a rectangular grid that is missing here. What do you think will be the area of the grid needed to complete the arrangement? It's easy. Since the length of the yellow grid is 3 and the breadth of the blue grid is 7, I have here a rectangular grid of 21 squares. It fills the gap perfectly. The rectangular area required to complete the pattern is 7 times 3 or 21. Adding the areas of all the 4 grids, we get x square plus 7x plus 3x plus 21, which is nothing but x square plus 10x plus 21. We'll now look at another way of verifying the concept. Look at the sides of the newly formed rectangle. The length of this big rectangle is x plus 3 and the breadth is x plus 7. The product of these two sides gives the area of the rectangle. In other words, x plus 7 into x plus 3 is equal to x square plus 10x plus 21. With this, we've proved and verified geometrically how to factorize a quadratic expression. Having learned how to factorize a quadratic polynomial, we'll now prove that the factors for the expression x square plus x minus 20 is equal to x plus 5 into x minus 4. We can split up the middle term into plus 5 and minus 4, which on adding will amount to plus 1 and give a product of minus 20 on multiplication. Hence, the expression can be split as x square plus 5x minus 4x plus 20. We have here two grids, a square grid for the term x square and a rectangular grid for the term 5x. We can place them together like this. Now, the area of the rectangle formed is x square plus 5x. The next step is to subtract two rectangles of area 4x and 20 from the existing rectangle. The shaded portions in this arrangement represent 4x and 20. Look at the sides of the newly formed rectangle. They are x minus 4 and x plus 5. It follows that x minus 4 into x plus 5 is equal to x square plus 5x minus 4x minus 20. Now, you can try and geometrically factorize any quadratic expression using grids.